Hello everyone, welcome to the next lecture on the testing of hypothesis. Today we will discuss about UMP test, that is called as the uniformly most powerful test. We will discuss about the one-sided. Myself Dr. Garg. You can simply follow my YouTube channel Dr. Harish Garg, where you can find various videos on the probability and statistics in an easiest manner. So whenever we are talking about the testing of the hypothesis, we always consider about the three cases. One of them is when your hypotheses are simple. What is the meaning of the simple is when your H0 and H1 are in the form of equality. This is the case 1. Second case is when it is of the one tail, that is whenever H1 is either greater than or H1 will be my less than of here. Accordingly, H0 will be, in this case, H0 will be my greater than of theta naught. This is the second case. Third case is when it will be of the two tail. Now we already discussed that how you can solve the testing of the hypothesis when it is a simple. That is, we already discussed about the most powerful test, which is available at my YouTube channel, this, and the title is here. However, if you want to test it for the case 2 and the case 3, then we will work on the uniformly most powerful test. Make sure this test is applicable only when such a test exists. What is the meaning of this uniformly most powerful test? So before defining this UMP, we will define the two definitions called as the size of the test and the class of the level alpha. What is the size of the test is? Any of the test phi of testing the H0 versus H1 is said to be size alpha if expected value of this function under the H0 is my alpha. And what is the class of this alpha? When it will collection of all those phi's whose expected value under the H0 is less than or equal to alpha, then it's called as the class of the alpha test. Once you are defining the size and the class, then we can define the UMP test. Any of the test phi which are used for testing the H0 versus the H1 is said to be the UMP test of size alpha when number one is it has of size alpha, that is it satisfies this property, and it has no smaller power. What is the meaning of the power is? We all know that I can written as power is 1 minus beta. What is the beta is? That is the probability of type 2 error. So we already discussed in detail what is the type 1 and the type 2 error. So it means if you have a test statistics phi, if it has no smaller power than any of the other test belongs to the H1, that is called as the UMP test. Mathematically you can write as whenever it is of the size alpha, that means if you find the supremum of all those test statistics phi, this is called as the alpha, and that is the power, that is the expected value of this phi is no smaller than, that means it will be a greater than or equal to of this. Otherwise, there is one more definition about that. Any of the test function or test status phi is said to be UMP whenever this POW is called as the power function. As I discussed, that power function is 1 minus beta, that is the power function is less than or equal to alpha, and for every phi dash, this is another test such that this power function of this phi is always be greater than of this. That's the same thing for here. This is the second definition about that. There is one more definition about the UMP test, that is any of the test function phi is said to be a UMP whenever you have a test statistics phi corresponding to this alpha, you have a size of corresponding to phi dash called as the alpha dash, and this condition holds, and 1 minus beta, that's a power corresponding to this, is always be greater than of the power corresponding to this phi dash. So we can use any of these three definitions where beta is the probability of type 2 and 1 minus beta is power. Now the question arises is does the UMP test exist always? So the answer is, in general, the UMP test does not exist for the one-sided problem. One-sided means that is for the one tail, whether it's a right tail or the right tail. So under what condition it will satisfy? That's the major question about the UMP test. So we can say it exists under the certain conditions, and that condition is whenever this phi will satisfy the certain family of the distributions, and this property is called as the monotone likelihood ratio property. That means whenever you say this phi will satisfy this monotone likelihood ratio property, then the UMP exists, otherwise not. Now the question is, what is the monotone likelihood ratio that we already discussed in our last lecture with the help of the 10 numerical examples in my previous lecture. You can watch this where you can get previous clear idea about that. I can quickly recall that any of the real parameter family of the distribution has a monotone likelihood ratio. Whenever you will think about that is a likelihood function of the f with respect to the parameter theta 2 over theta 1 is always be a non-decreasing, or you can say it's a non-increasing. That's a monotonic are there. Whenever the function is a monotonic over this condition, then it's called as the monotone likelihood ratio. Here the term is the set of the existence. That means both, either or both are my positive numbers, and if whenever this number is my greater than 0 and this number is my 0, then this number will goes to the plus of infinity. Now what is the existence of this UMP test? So once you will prove that, this is clearly say that this is the one tail. So once you will prove that the corresponding distribution function, that is a family of this distribution corresponding to this H0, will satisfy this monotone likelihood ratio in T of x, where what is the Tx? Tx can be of product of xi's, it can be of sum of xi's, it can be minus of log xi's, log x, it can be minus of log of this, or it can be of x raised to power alpha are there. So any of the function which is form of this one. Whenever the family will satisfy this monotone likelihood ratio, then you can define this UMP test by using this Carlin and Rubin theorem. It is abbreviated as KR theorem. That is, phi is my test statistics. If you prove that it is my monotonically increasing, then you can write as a greater than equal to k, as a 1, equality is k, and so on. If you prove that this monotone likelihood ratio is my decreasing, then you can define the phi value as 1 corresponding to this is my less than k, and equality is my gamma, and greater than k is my 0. So that's depending upon the monotone, which kind of the monotonic is here. Then this function has a non-decreasing power function and the size of the alpha is my positive. Then you can clearly say that the k is my unknown. So how you can find that? That is by the definition of the UMP, expected value should be alpha. So we all know how you can find the expected value in case of the probability. So if it is a discrete, then you can write like this way. If it is a continuous, then you can write like of this way, where P, this is my PMF, this is my PDMP. So accordingly we can define like this way. This is my random variable, this is my probability. So I can write like of this. There is a 1 of this, gamma times of this, and 0 times of this should be alpha. Clearly says that when you have a continuous random variable, then we all know that probability at a single point is always be a 0. We already discussed several times. Probability at a single point is always 0 for the continuous random variable. So this value will be 0 always. Hence this number will goes to here. That is, whenever it's a greater than k, it's a 1, and unknown number is 0. Now there are the different form of the UMP test for the one-sided. So first of all, you have to satisfy this monotone likelihood ratio. Then based on this monotonic property, whether it's a increasing or decreasing, and depending upon the nature of this H0, whether it's a left tail or the right tail, we can define here. Suppose firstly it's a non-decreasing, that is means it's a increasing. So once it's a increasing, you can define the value of the phi according to the nature of H1. So if H1 is my greater than, then you can define this as my greater than is my 1. On the other hand, if again it's my increasing, so we have to define according to the nature of the H1. H1 is my less than sign, so we can define the corresponding value is my 1 is less than here. Here is a non-increasing, that means it's a decreasing function. So we have to reverse the sign of the H1. H1 is my greater than, so we have to write as a less than. If it is a less than, then we have to write as a greater than answer. So make sure based on the nature of this monotonic likelihood ratio, we have to define the UMP test. Now what are the steps? You have to construct the compound hypothesis. How you construct the UMP? We will discuss a 3-step rule. The first step is you have to check the monotone likelihood property. If this satisfied, then only the UMP test exists. How you can do that? We have to see like this way. Once you will prove that it's a monotonically increasing or decreasing, so let's say it's a increasing, then you have to write this as a greater than according to the nature of this. If it is a decreasing, then you have to reverse the sign of the H1. And how you can find the value of K? That in my step number 3, you have to find the expected value. Now let's discuss the 10 examples in this lecture so that you are able to understand it very clearly. So let's start with the first one. So what is given to you? This is a family because it consists of the more than one element. So you have to define the likelihood function like of this manner. So the PDF is given to you. This is my PDF. So you can find the likelihood function like of this. I denoted the likelihood function as f of this. This is my here. You can substitute here. Now we can apply the step number 1. That is, we can start with the monotone likelihood ratio. There is an unknown parameter is my theta. So I can write as a theta 1 is less than of here. What is the value of this? We can substitute here. Theta of this product of xi's of theta 2 minus 1 divided by corresponding to theta 1. Clearly says that this is my less than sign and this is here. So UMP test will be applicable. So what I can do, I can write this number in the form of this one. Now our target is to check whether it's a greater than 0 or less than 0. Now clearly says that theta 2 is my greater than of theta 1. So this number is my positive. So once this number is positive, product of the random sample is a positive number. This is my positive number. Theta is always be a positive number. So the ratio of the two positive number is always be a positive. So hence it is a increasing function. And what is the function of the axis? Function of x is my product of xi is called as t of x. That means the UMP exists for this function. That means this is my monotonic likelihood ratio in this t of x. Once it's a likelihood ratio, then we can define the value of the phi corresponding to the nature of the H1. H1 is my greater than, so we can write monotonic in product of xi's are here. How you can define the unknown number c? We will use the product of this, but before that we can try to simplify it more. This is the critical region. So how you can do that? I can take the logarithm on the both side, which can be written here, or you can write it as minus on the both side, which you can see this is the c dash, where c dash is another constant here. So therefore, since now u is less than of, I can say this is my u is less than of the c dash. So I can replace this number as u is less than of c dash. So my target is to find the value of the c dash. How you can find the value of c dash? That is by using this property. Now what is that? This is nothing but y1 probability of u is less than of the c star under my h0 condition. Fine. So how you can solve that? Now it's a continuous random variable. So you can integrate over the lower limit is 0 over the c star. What is that? This is the function of u. Function of the u. So but this is the function of the x. So what is the PDF of the u? So it means our first target is to find the PDF of the u. How you can find the PDF of u? U is my sum of the log xi. That's very simple. You can use the transformation. I firstly start with the y is equal to log x. How you can find the transformation? This is the distribution of here. What is the value of this? I can find the value of the x from here. X is my minus of dy. What is the dx upon dy? This is minus e raised to power of here. So what is the modulus value of this? This number is my e raised to power minus y. What is the value of this? Here add the value of the x. So I can written as e raised to power minus y of theta minus 1. So I can take the pairs. We can written as of this. So do you know which distribution is here? Yes, it is a exponential distribution. Now y, this is my log of x is my y, but I need minus of log of x. What is the meaning of that? If y follows my exponential distribution, then sum of the exponential distribution will be, yes, it's a gamma distribution, and this is a summation varies from the n. So therefore this quantity will goes to my here. Now how you can solve that? We can see 0 to c star. What is the gamma function is? Gamma function of the n. What is the first parameter is? X raised to power n minus 1 e raised to power x upon theta of this. This is the value of this. Now how you can integrate them? That is not possible because of the incomplete gamma integral. So other way you can see this is nothing but my upper quartile of this gamma. So you can take this upper quartile from the gamma distribution table and substitute this value here. You will get the UMP test. Look at the another one. Again a sample, a random sample is given to you. So you have to firstly define the likelihood function. What is that? You can simply write like of here, because this is the 1 by theta raised to power n. Now you have to check whether it's a monotonic likelihood ratio or not. We can start from here. We can substitute the value. You will get here. You can summarize this pair, exponential part, which is this. Again, theta is my positive number, so this part will be my positive. Theta 2 minus theta 1 is always be a positive number. Moreover, exponential function can never be negative, so this is also be a greater than 0. Hence, it's a monotonic likelihood ratio in the form of the x. X is my summation of xi. So therefore, it is a form of this. So we can define the h. What is the h0 is my less than of this. So h1 is my here. It's a greater than sign. So we can define like here. How you can find the unknown number t0? That is here. Again, because it's an integration, so it's a t0. The largest value is my infinity, but it's a function of the t. But here is a function of the x. Again, we need a transformation. So you have to find the transformation of t. That is my xi. How you can do that? We all know what is that? This is the exponential distribution. Once xi is exponential distribution, some of them will be a gamma distribution. Hence, this part will becomes my here G, where G is my PDF of gamma distribution under the h0. What is the h0 is here? So we can substitute this value under this one. Again, this is an incomplete gamma distribution. So where t0 is found from the incomplete gamma distribution table. Once you find the gamma distribution table from here, you can write it as this. Otherwise, you can skip here. That's also the fine statement for your examination point of view. Look about here. In this case, it is an equality here, but h1 is my greater than 0. It means again the UMP test will be applicable. That's a very important question for you. So we can start with that, because you can see that there is a family of this. We can start from here. What is the family of here? We can write like this way. So you can see h1 here. We can write this number, but h0 is always given as a 2. So we can write instead of the theta 1 is like here. Fine. So that's why this is h1 divided by h0. So what is the value of the here is, we can substitute this and we can simplify, we can get here. Whether it's always greater than 0 or less than 0, we can easily check that. We can take that derivative here. We will check whether it's a greater than 0, because we all know whenever the derivative is greater than 0, it means the function is increasing, and whenever it's a less than 0, function is decreasing. So you can see once you simplify them, you clearly says that theta is my positive number, theta minus 2 is always the positive number, x is my positive number, so this number is positive, this number is positive, so it's a increasing function. Once it's an increasing function, we can write according to the h1. h1 is greater than, we can write here. How you find the unknown number? We can write here. So since it is a function of the x only, so there is no need of the transformation. So how you can solve that? We can take the integration from x to the upper limit is infinity. Now you can easily solve the integration of this. We will get the value of k as here. So I can substitute the value of k here. We will get the UMP test as this one. Look about the another one. Okay, so clearly says that this is the answer. Now how you can solve this second part? So there is no need to solve the second part again in a similar manner. Remember, look at that. This UMP test is my independent of theta. Clearly say that this is totally dependent upon alpha, but it is independent of theta. It means the same test is used for h0 is less than equal to 2. That is, the right answer of the B is also with the same one. If you want to solve the similar manner, you can start with them. Otherwise, you can start from here. Instead of this, you can write this as a theta 2. Here is as a theta 1, and then try to solve. But this is a simple remark for you. Whenever the test statistics is independent of the unknown parameter is my theta. So it means the same test is for the other test statistics as well. Okay, look about this one. So find the UMP test of this in this case of the no data problem. What is the meaning of that? The no data problem means that's a single observation. Once it's a single observation, what is the likelihood ratio? That is product of I is 1 to 1. That is my same thing. That is my here. What is the this is the uniform distribution, and you know that the PDF of the uniform distribution is 1 over b minus a. So what is the value of this? This is 1 over minus 1, that is my 1. Or I can write this function as in form of the I, that is a unit length of over this. Now we can start with the likelihood ratio. We can substitute this value, that is this value for this theta 2 and here. What is the meaning of that? You can see theta 1 is less than of theta 2, fine, and theta 2 is always be less than of the theta 2 plus 1 as per the interval. Now where is my theta 1 plus 1? Can it be here or it can be here? There are only two options are there. So it means there are the two cases. The first case is when theta 1 lies in this side, otherwise it lies here. Now how you can check whether it's increasing or decreasing? You have to check whether it's increasing or decreasing. We consider the cases. Look at that. What is the meaning of that? This is the unit interval. So it means the PDF is my 1, and in this case PDF is my 1. So I can try to substitute the value. Whenever x lies here, what is the value of this? What is the value of this? That is for the theta 2 lies outside, that is a 0. What is the value of this? Again it lies outside, that is a 0. So it's a 0 by 0. Whenever x lies in between them, the numerator value will be my 0. The denominator value will be my 1, because it's a uniform over this domain. Whenever x lies between here, the numerator value is my 1, denominator value is also my 1, and so on. So we can see the values are here. Now you can check whether it's increasing or decreasing. For the, now this is the unexistence, this is the unexistence. So these are my existence. Clearly says that it's a increasing 0 to 1 to infinity. So we can say it's a non-decreasing in the defined in the interval of this to this. Similarly for this case, what will happen? In this case, this value is my 1 because it lies in here, and this value is my 1 according to the probability density function. So whenever x lies here, so this value is my 0 by 0, undetermined. Whenever x lies between here, the denominator is my 1, but the numerator is my 0. Whenever x lies between here, it lies outside them, so denominator will be 0, numerator is also 0, and so on. So clearly says that these are the undefined, and for the defined things again shows that it's my increasing. So hence this likelihood ratio is my increasing function. So once it's an increasing function, we can write this form of x is greater than. How you find the x0? We can solve this one. So this is a function of the x, so we can write here what is the integration of this. So x0, the maximum value will be theta 1 here, but under this h0, what is the h0 is? Theta naught. So I can write this as x0 to theta naught plus 1. Can you find the value of x naught from here? You can easily solve that. You will get this as. Substitute this value here, you will get the UMP test as this one. Look about this is the problem of the discrete. This is the problem of the discrete. Lastly, examples are my continuous. You have to test the UMP test. Remember, this question is always asked in the CSIR net. Such kind of the questions are always be asked in the form of the gate examination. So remember, this is a very simple question. Within a fraction of the second, you can get a 4.75 in these examinations. So what is that? Whenever you are working on the discrete problem, then you have to use the Niemann principal lemma. That is, again the similar thing are there. What is the meaning of the h1 over h0? You can also define like f of, this is the same thing. That is, this is the same thing corresponding to here. So it means you have the f0, you have the f1, you can firstly take the compute the values of this, like 0.02 divided by 0.01 here. Now out of these you can simply list the values 2, 5, 1, 21 and 0.25. These are my values which are taken from here. Then we can pair them. It means if you look at the table, if these are my values 1, 2, 5 and 21. So how many pairs are there? The first pair is my here, second pair is my here, third pair is my here, fourth pair is my here, fifth pair is my here, sixth pair is my here. So let's start with the first pair. That is x1 is 21 to infinity, that is this pair. second pair is 5 to 21, third pair is 2 to 25, and so on. So we can see like this. So firstly we will see about this. Take any number which is lies in this interval. So say k is equal to 25. Look at this. Look at the any value, that means the ratio will be greater than of 25. Do you have any value which is greater than of k of this interval? No. So then we can define the critical value. This is my, what is the value of this is 5. Fine. So once it's a 5, you have to find the probability corresponding to the H0, that is my 0. Any number, choose any number between 5 to 21, let's say 10. What is that? Find in this table whose value is my greater than of the 10. Do you get any value? This number. This is corresponding to 4. So W is my singleton set, that's my 4. And what's the answer of this? Look at the H0. What is the answer of the W is 4 is 0.03. Fine. But we need a 0.05. So this case is not acceptable. We will look about here. Choose any number between 2 to 5, let's say 3. So look at these values in this row which is greater than of the 3. So this number, this number. There are the two values. So we can consider as 3, 4. And we will check if it is a 0.05, we will stop. Otherwise we will take about the next pair. What is the 3, 4 is? 3, 4. So what is the answer of this? 0.05. And that is our target because of the size 0.05. So it means the UMP test exists for the 3, 4 because it's a discrete number, so you can write as a this answer. And after that, if you want to find the power of the test, so you can find the power of the test from the H1 respectively. Okay, again look at this. This is the continuous. So you have to find the UMP test for two different cases. So look at that. Firstly, you have to find the likelihood ratio because it's a function, it's a family. So you can write like here. Now the one way is, since the unknown in the first case alpha is my fix, so I can take alpha is my alpha node. So it means I can start beta 1 is less than of the beta 2. I can define the likelihood ratio as of this and of this, and we will check whether it's increasing or decreasing. But there is no need of them because we have to see it's an exponential are there. So whenever there is exponential, we will try to compare with the exponential family. That part I'll already discuss in the monotonic likelihood ratio lectures. If you compare them, this is a function of the parameter only. So which one is? This is the function of the parameter only. So this is my d of theta. In this case, theta is my beta. This is the function of the x only. So you can see this is the function of the x only. This is my here. E raised to power here. This is a function of the parameter. This is the function of the x also. So you can see this is e raised to power 1 upon beta summation of xi. So clearly says that this is the function of the parameter. This is the function of the t of x. So you can see this is my tx, this is my here. So what is the meaning of that? It is a monotonic likelihood ratio in this summation of xi. Hence it's an increasing function, so we can write this function as here. The target is to find the value of the t0. We can written like here. It means how you can solve them. You can solve the integration from t0. Upper limit is my infinity, but this is the PDF of the t. But how you can find the PDF of t? It is unknown to you, so you can find the PDF of. What is the distribution here? Xi follows my gamma distribution, and we all know that the sum of the independent variable of the gamma distribution is again a gamma distribution. So therefore we can start from here. G is my PDF of the gamma distribution with the parameter n alpha comma beta. Under the H0, what is the H0 is beta naught, so I can written as a beta naught. Again it is an incomplete gamma distribution, so you can write as such from here. Similarly you can try for here. This is a similar manner, you can do it by yourself. Okay, look about another one. So again it's a uniform distribution. You have to find the testing of here. What is the PDF corresponding to this? This is 1 by theta. Corresponding to the family, what is the likelihood ratio? That is my product of 1 by theta. I varies from 1 to n. So it is my 1 by n. Fine. But because of this continuous, because of this we can substitute this is my capital T, as we already explained them. This is the maximum of x size. So that is the random variable out there. Now how you can do that, again we will see. We know theta naught is less than of the theta 1. So there are the two cases, either the parameter lies in here or it lies in here. What will in this case, what will happen if it lies less? Okay, firstly we will see here, if it lies in this case, what is the value of here? T1 is less than, so whenever its value is here, the value will be my this. Whenever it is less than of this, the value will be my 1 by theta naught raised to power n. So clearly says that whenever this value lies in here, we will get the numerator value of this, denominator value as of here. Whenever it lies in this case, this value will be 0, because this value is only be here, otherwise 0. So that means denominator is 0, so value is my infinity. So we can simplify here. And clearly says that this value, because it's a uniform distribution, theta is greater than 0, so this number is my positive, so that's a increasing monotonic ratio. Once it's increasing, we can define the UMP based on this greater than sign. Again, it's a t, we have to define the distribution of the t. What is a t? That's a maximum of xi. Well, how you can find the maximum of xi? That's the ordered statistics. We can know the density function of here. What is the capital F is? That's the CDF of this x. What is the x? Uniform distribution. So what is the uniform distribution CDF? So I will tell you, if this is my uniform distribution, then the CDF of this is my x minus a over b minus a. In this case, what is my a? A is 0, b is my theta. So what is the distribution? This is x over theta. So I can substitute this value here. PDF is my, what is the PDF of the uniform distribution? 1 over theta. So I can substitute this value in this form. Now this is the PDF. You can substitute this value here from this to this. This is integration with respect to t under the h0. H0 is my theta naught, so I can substitute this value as theta naught. Now you can simplify them. You will get the value as t0. Now since it is a value here, you can substitute this value. You will get as UMP test. Okay, look at the another one. So it's you have to check the UMP. That's again there is no family given to you. Is it given to you x1 up to xn? No. So there is no need to find the product of the likelihood. This start from directly here. We can substitute this value. How you can check whether it's a maximum or minimum? You can take the derivative. You can simplify this bracket. You will get here. You can take the e raised power minus x common, and here clearly says that theta 2 is my greater than of this. So what is the meaning of that? This number is minus of this, because we all know that e raised to power minus x is a decreasing function. So it means it's a monotonically decreasing. So once it's a decreasing, you have to reverse the sign of the h1 in writing the phi x. You can see. How you find the x0? We have to use this. What is the lower limit is minus infinity. We can see from minus infinity to here. How you can integrate them? That's very simple. You can take the integration of this. You can solve them. You will get this answer. Can you find the value of the x0 from here? Yes, you can do that. You can take the logarithm on the both side. You will get here. You can substitute this value. You will get the UMP test. Okay, look at the last example. So xi's are my normal distribution with ai, 1. I varies from here. So I varies from 1. That is, it is x1, x2 and xn. So we have to use the likelihood function. Firstly, you have to write the PDF of this. We all know this is a variance, so it is a sigma is here. Based on the likelihood, or you can open this a minus b whole square, you can see it in here. Based on the likelihood function, we can write of this product of this value of a, which is written here. Again, because of this exponential family, you may start from this like of a2 divided by x of a1. I consider this as lambda x whenever a1 is less than a2, and check whether it's increasing or decreasing. But because of this exponential, we can simply compare the exponential family here. Look at that. This is the function of only exponential. So this is my s. Our target is to find the value of tx. So what is that? This is my parameter theta. This is my here. So you can see t of x is my this and here. Now it has a monotonic ratio, so it has a uniformly testing RT, which is here. How you can find the t0, which is my here. But you need to find the test statistics distribution of this t. What is that t is? Here. How you find that? That's very simple, because xi follows my normal distribution. So we need the I of xi. So what is the I of xi? What is the mean of the I of xi? That's the mean. How you can find the mean of I xi? I is outside, E of xi. What is the mean of the xi is I square a. So this is my I square a. This is a variance. How you find the variance of xi? This is I square is outside, variance of xi. What is the variance of xi is 1. So it is my I square. Fine. So this is my here. Now we need the summation of this. We can use here. Now once it's a normal distribution, so we all know how we can use the normal distribution. We can convert them into this standard normal variant. So what is that? If a t is there, we can subtract summation of xi square on the both side and here. Now what is that? How you can solve this is based on the normal distribution. You can simplify that. This is my required, because you can see that this is, you have to find the value at a is equal to 0. So you have to, what is the value of this at a is equal to 0? It is my 0 of I square. So I can convert them to be the normal distribution. T minus 0, that is a mean, divided by root of the variance. So root of variance is my here. So this where z alpha is my, because it's a greater than, so it's the upper quartile of the standard normal variant. Can you find, this is the summation, I varies from 1 to n. So you can open this. What is that? This is my here. Substitute this t0 value as here. You will get the right answer of this UMP test. So this is the way you can solve this UMP test in a very simple manner. Make sure that the most important concept is you have to understand this monotonic likelihood ratio. We will see the next lecture on the two-sided UMP test, and we will check whether there is an existence of this or not. I hope you can simply learn this concept in a very simple manner. You can simply like, share and comment on these videos. Best of luck students. Happy learning.